Hello, in this video we will talk about naming alkanes that have rings in them. I will assume that you've already learned by reading the book and by watching previous videos that you've learned the IUPAC system for alkanes without rings in them. In this video we'll just add a few more rules. You might want to read sections 4.2a before you view the video. First thing, very simple, the ring itself is named as if it were the same number of carbons in an alkane, propane, butane, pentane, and so on, except you put a cyclo in front to indicate that it's in a ring. So cyclopropane, 3-carbon ring, cyclobutane, 4-carbon ring, and so on. And those are just the names of those alkanes. Don't need any numbering system. Now, what if there is a ring with one carbon group on it? Well, that carbon automatically becomes carbon number 1. So that's number 1 here, that's number 1 here, that's number 1 here. We don't need to worry about any other numbers in the ring because there are no other groups. And you don't even need to put a 1 in front of the group on the name because it's automatically number 1. So methyl cyclohexane is this compound, and it wouldn't matter where you attach it on the ring. It would just be the same thing except turned in space. So we just call it methyl cyclohexane. This is another example, ethyl cycloheptane. This one a little bit more complicated. Remember, the name 1-methylethyl is actually the IUPAC name for this group, which commonly is called isopropyl. So you would see, for example, some people calling this isopropyl cyclohentane, but technically you can't use isopropyl because it's not an IUPAC name. So we number the side chain 1, 2, put the methyl group on carbon number 1. So it's a 1-methylethyl group. And the reason we put it in parentheses is because we don't want whoever's reading this name to think that perhaps the methyl is referring to something on the ring. So the 1-methylethyl, the whole thing, is on the cyclopentane. So now, what if you have two groups on a ring? Well, if they're the same as each other, in other words, two identical alkyl groups, it's very easy. One of the two groups that are attached is number 1. In this particular case, they're both attached to the same carbon, so they're both on carbon number 1. So we go 1,1 dimethyl cyclohexane. Don't forget you need to put both numbers in, even if they're the same as each other. And you might wonder, well, why couldn't we just leave them off altogether and call it dimethyl cyclohexane? And the answer is because then whoever was reading that name wouldn't know where the two methyl groups were on the ring. So you have to indicate that they're on the same carbon by putting a 1, 1 in front. This one, again, two groups the same, ethyl groups, but they're not on the same carbon. So that one becomes carbon number 1, and we have to number around to whichever direction will get you to the second one as soon as possible. So if that's number 1, that's 2, that's 3, as opposed to if that's number 1, 2, 3, 4, 5, 6. So obviously we want to go this way. But you might say, well, couldn't that be number 1? And then we go this way, 2, 3, and the answer is, yep, that's exactly right. But it still gives you the same name, 1,3-diethyl cycloheptane. Same thing here. We call that one number 1 and that one number 2, or that one number 1 and that one number 2. It's the same thing. The name of this group is, again, that 1-methylethyl group instead of isopropyl. And now we see clearly why you need the parentheses, because this number 1 is different from that number 1. This number 1 is referring to the number 1 carbon on the side chain. That number 1 is referring to the number 1 carbon of the ring. So don't forget, if you have a branch on a branch, the numbering system within the parentheses is different, referring to a different set of carbons than the numbers that are in front of the whole name. Now, what if you have two alkyl groups on a ring, but they're different from each other? Well, if they're on the same carbon, it's easy, because that's automatically carbon number 1. So in this case, it's 1-ethyl, 1-methyl. Don't forget, you list them in the name in alphabetical order. But here we have two groups that are not the same as each other, and they're not on the same carbon. So then you have to decide, is this carbon number 1? And we number around this way to get to carbon number 3. Or is this number 1? And we number around this way to get to carbon number 3. The answer is, since you have no other way of knowing, you have to go by alphabetical. So that's number 1. That's number 3. So it's 1-ethyl, 3-methyl cycloheptane. Similarly, is this number 1 and that number 2, or vice versa? Since you get the same branch points at the same time either way, we're going to go alphabetical. Since E comes before M in the alphabet, that's number 1, that's number 2. So 1-ethyl, 2, parentheses, 1-methylethyl cyclopentane. Now, what if you have 3 or more alkyl groups? Well, you have to find one of those positions where an alkyl group is attached that will get you to the next branch point as soon as possible. And if you can't decide then, you have to go to the next branch point after that as soon as possible. In this case, it's easy. If this is number 1, we get to the next branch point also at carbon number 1. Whereas if this is number 1, we don't get to the next branch point until carbon number 2, and carbon number 2, and so this is number 1, that's number 2, so it's 1, 1, 2 trimethyl cyclohexane. Again, you need a number for each group even. Let's look at this molecule. What we have to do is decide among each of these 3 carbons which one should be number 1. If that one's number 1, we number around to get to the first branch point of carbon number 3. Whereas if this is number 1, we number around to the next branch point of carbon number 2. If this is number 1, we number around to the next branch point of carbon number 2 also. So this cannot be number 1, but these each still could be based on what we've said so far. If we start here and go to the first branch point as soon as possible, that's that one, so that's number 2. And then 3, 4, 5, 6. We don't get to the next branch point until carbon 6. Whereas if this is number 1, we go 1, 2, 3, 4. We don't get to the next branch point until carbon number 4. That's less than 6, so therefore that's number 1, 2, 3, 4, and we call it 1, 2, 4 trimethyl cycloheptane. And finally, what about this one? Well, even though E comes before M in the alphabet, since the first branch point, after this is number 1, we get to the first branch point also at carbon number 1. This one is carbon number 1, so it's 1, 1 dimethyl and 2 ethyl. But don't forget E comes before M in the alphabet. We don't use the D as a decider in the alphabet. We use M as a decider in the alphabet. Now what if we have 3 or more alkyl groups? Here's some more examples with 3 or more alkyl groups. Should that be number 1? In which case we get to number 2 as soon as possible, or should that be number 1? In which case we get to that one, number 2, as soon as possible. Well, the answer is that should be number 1 because that's number 2, 3, and that's number 4. So the name is 2-ethyl 1,4-dimethyl cyclohexane. Now in this one, all 3 groups are equally spaced around the ring. So in whichever one you call number 1, you'll get to the second branch point at carbon number 3, and the third branch point at carbon number 5, no matter which one you choose as number 1. So how do we decide? Well, we decide based alphabetically. So since E comes before M, we're going to use that one as number 1. And if that's the case, in this particular example, we'll get to the next branch point at carbon number 3 either way, and the following branch point at carbon number 5 either way. In fact, it really doesn't matter. So that's number 1, 3, 5. So 1-ethyl, 3,5 dimethyl. Well, what about this case? These are all different from each other. You can't really call that one number 1, because if you did, 2, 3, 4, 5, 6, you wouldn't get to the next branch point until carbon number 6. Or, again, starting with this one is number 1 if we went this way, 2, 3, 4, 5, 6. So that one really can't be number 1. But this one could be, because we'd go 1, 2, 3. Or this one could be, because we'd go 1, 2, 3. So which one do we choose? Again, alphabetical. M comes before P in the alphabet, so that's number 1, 2, and 3. So it's 2-ethyl, 1-methyl, 3-propyl. And again, these are listed in that order in the name, simply alphabetically. E comes before M, M comes before P. Here's another example with 3 or more alkyl groups, since, again, this is similar to one we saw before. All 3 are equally distant from each other on the ring. So which one is number 1? Well, the only way I have of choosing is alphabetical. So that's number 1 because E comes first. That's number 3 because M comes next in the alphabet. And that's number 5 because P comes last in the alphabet among those 3. So there should be 1-ethyl, 3-methyl, 5-propyl cyclohexane. And finally, let's look at this example. How are we going to decide which one is number 1 here? It's pretty clear that's number 1 because it has 2 groups on it. In other words, if that's number 1, then the first branch point is also at carbon number 1, and that's quicker than any of the other possibilities. And we number around this way to get to the second branch point as soon as possible, so that's number 2, and then 3, 4, 5. So 1, 1, 5, triethyl, 2-methyl cyclohexane. Now, last thing, it is possible that you could have a very complicated side chain and a simple ring somewhere attached to the side chain, in which case then it is acceptable to find the longest straight chain of carbons. In this case, it would be 5. 1, 2, 3, 4, 5. So we're going to call it a pentane, not a cyclopentane. But the cyclopentyl is a group on that chain. So in some cases, you can turn the name of a cycloalkane into the name of a cycloalkyl group. So this is 1, 2, and on carbon number 2 we have a cyclopentyl group, 3 we have a methyl group, and then 4 and 5. So it's 2-cyclopentyl, 3-methyl pentane. And in some cases, you may have 2 rings attached to each other. So how do you decide in that case which one is the alkyl group and which one is the basic part of the name? Well, it's whichever one's bigger. So cyclohexane is the base part of the name, and then the cyclobutyl group is a substituent on the cyclohexane, so it's cyclobutyl, cyclohexane. Now, there are more complicated situations where you might have groups attached to one or the other of these, or you may have 2 groups that are the same size with different groups on 2 of them, but that's a little bit beyond where we need to worry about for this particular chapter. Now, go back and reread section 2.4a,